This script code provides examples of TO sampling. The methodology allows for the creation of realistic synthetic data, even in some cases where the data may be sparse. I am Haley. How may I help you?
Hello, Haley. Can you hear me clearly?
Yes, I can hear you, Dr. Stokely. How may I help you?
Good that you can hear me. Would you please run my Monte Carlo demonstration program?
Confirmed. Roger that, Dr. Stokely. Executing code now. Start Monte Carlo sampling of existing two-dimensional distribution. $150,000 Monte Carlo data samples have been created. Press a key to proceed with figure displays. Creating comparison figures. A two-dimensional surface distribution is shown in the plot on the left. The plot on the right is a two-dimensional histogram that was generated by the technique of Monte Carlo sampling. Monte Carlo sampling can be extended beyond the case of sampling from one-dimensional distributions. This demonstration video shares an example of how to do Monte Carlo sampling from a two-dimensional distribution. The first example is for a large number of Monte Carlo samples, 150,000 Monte Carlo draws. Fundamental to Monte Carlo sampling is its reliance only on a random number generator. There are many Monte Carlo techniques that can generate synthetic data, including methods on how to oversample rare events. There are also Monte Carlo methods to sample from the most challenging scenarios. An example scenario would be to sample from a complex phase space manifold of high dimensionality, likely with sparse regions, and in some cases, also includes variables with discontinuities or discretized data. One of the famous algorithms of Monte Carlo is the method of Latin hypercube sampling, and it is related to stratified sampling methods. The Latin hypercube technique can often produce a superior sampling of the system phase space that would not otherwise be feasible using random sampling alone. There is also another technique that has proven successful, and it is called orthogonal sampling. This sampling method is closely related to the fundamental ideas of the major paradigm in signal processing called compressive sensing. Footnote: the Latin hypercube sampling technique was primarily developed for nuclear physics research at the United States Los Alamos National Laboratory about 40 years ago. Another factoid: the mathematics of compressive sensing has resulted in at least one mathematician winning the extremely prestigious Fields Medal. The next example shows the results for 1,000 Monte Carlo draws, instead of 150,000 samples used in the previous example. Press a key to continue. The choppiness in the synthetic two-dimensional histogram is very striking. This may be a situation where more sophisticated techniques such as orthogonal sampling or Latin hypercube may be absolutely necessary. Those are only a few examples of the many approaches that might be useful for solving real-world problems in the areas of machine learning. This concludes this brief presentation. I offer an open invitation for a more in-depth discussion on this topic, which would focus on the methods of global sensitivity analysis. Thank you very much for your time in reviewing this presentation. I welcome feedback.
Thank you, Haley.
Back to you, Dr. Chris.
Thank you, Haley. That was very good. Good job. This concludes our presentation.